All right, so when we're talking about factoring, here's what I want you to start by writing down. I want you to write this down. Factors. What factors are? Factors are things being multiplied together. Things that are being multiplied together. Is the microphone too loud? No, it's not. Okay. So for example, 2 plus 4, those are not factors. 2 and 4 are not factors in that case. However, if I wrote it like this, those are factors. 2 times 4. Okay. 2 plus 4, the 2 and the 4 are not factors, but when I write it as a multiplication problem, then they are. So if you look at this example on the left-hand side, I have 8 times 7 equals 56. If we're going from left to right, 8 times 7 equals 56, we're multiplying. But if we start at 56 and go backwards, so this is multiplying, going backwards, starting at 56 and breaking it down into 8 times 7, that's called factoring, because we broke it down into 2 factors, 2 things being multiplied, the 8 times the 7. And that's just with numbers. Over here, it's the same. If I did 2x times parentheses x plus 3, that's a distributive property, right? That's multiplying. That gives me 2x squared plus 6. But what we're doing today is we're starting here at something like that, 2x squared plus 6, and learning how to break it down into factors like that, 2x times x plus 3. And one thing I want to point out here is that a moment ago, at that example up top, I told you 2 plus 4 are not factors, but 2 times 4, those are factors. Right here at this step where I said these are factors, here's what I mean. I mean this 2x is a factor, and this entire group x plus 3 is a factor, okay? Because the x is not a factor, 3 is not a factor, because those are being added together. But when you take the entire group that has parentheses around it, that all of that yellow is one factor, and all of that blue is another factor. Okay, so that's 2 things that are being multiplied together. So it can still have a plus in there as long as that plus is part of a bigger group. All right. So keep that in mind as we work through the problems. And then right under there is the definition for greatest common factor, in which we're going to call the GCF. The GCF of 2 or more expressions is the largest expression that is a factor of all the expressions. Isn't math, this is like math speak, right? Sometimes it's just you have to be very specific and accurate, then it ends up sounding like I don't know what they're saying. Let me break that down for you. If I give you 2 numbers like 9 and 12, and I say, what's the biggest number that goes into both of those? What would you say? 3, right? That means that the GCF of those 2 numbers is 3. So here's how that works. I asked you, I said, the biggest number that goes into both. So I said biggest, that's where this G for greatest comes in. Goes into both, that's where the C for common comes from. And then goes into, that's the F for factor. So that's why when I say, what's the biggest number that goes into both, I'm really asking you, what's the GCF? What's the greatest common factor? So then we are going to, so that GCF 3 was just for 9 and 12. And that's great. You know how to do that. But what we're going to do is practice finding the GCF when there's not just numbers, but also variables, right? So in this first example right here, we're going to find the greatest common factor of those 3 terms. And our very first step is to factor each coefficient into primes. The coefficients are the number pieces, like 21, 9, and 15. And then we will write all variables with exponents in expanded form. So like, for example, for 21x cubed, how do I write x cubed in expanded form? X times x times x, right? Exactly. So here's how that step one will look for these terms. 21x cubed, I can do a factor tree for 21, 3 and 7. And those are both prime already, meaning I can't factor them anymore. So I'll rewrite 21x cubed as 3 times 7 times x times x times x. And then I'll do the same thing for 9x squared. 9 is 3 times 3. So I have 3 times 3 times x times x. And then 15x. What is 15? 3 times 5. And what I'm looking for are factors that they have in common. So looking at the numbers, what numbers do they have in common? They have a 3, and that's it. How many x's do they have in common? 1, just the 1, right? And so when we go to say what their greatest common factor is, we say, okay, they have a 3 in common times 1x in common. And what is that? That's just 3x. And that's your answer. And after we do these for a while, we won't have to write it all out long. We'll be able to do it in our heads. Or with just a little bit of math. Okay? You try number 2 on your paper. Try number 2. $25 and $35 can only be factored 5 times 5 and 5 times 7. However, on 20, there is something there I need to point out to you. You have to factor numbers like 20 down until you can't anymore, meaning you wouldn't leave 20 like 4 times 5, because 4 can factor more to 2 and 2. Or, for example, you wouldn't leave 20 as 10 times 2, because which of those factors more? 10. 10 is 2 and 5. So always factor as far as you can until all you have left are primes. Primes are just 1 in themselves. Okay, so then, having said that, let's find what they have in common. What numbers do they have in common? They have a 5. And how many m's do they have in common? All right, so when we go write our answer, we write down that they have 1 5, and then an m and an m. And that means 5m squared. Okay. And you try number 3. Hayden, please tell me how you factored 14x cubed. What did you write? Thank you. Krislan, how did you do 70x squared? 10 and 7? Okay. And 10 factors more. How can I break down 10? And then there's 2 x's. Maggie, how did you do 105x? How'd you do 105? Okay, and 1x. Thank y'all. Megan, what numbers do they have in common? Number or numbers? They have a 7. And how many x's do they have in common? 1. And so our GCF is 7 times x, which is 7x. All right? So what we just did was find the GCF of multiple things. What we didn't do anything with was with the leftover stuff. Like we used the highlighted stuff, we wrote a GCF, but this next section we're going to do is we're going to do something with everything that was left over as well. Right? So all we did now was find the GCF. Now we're going to have these examples where we factor out the GCF and write the leftover factors in parentheses. What we're going to do basically is this thing right here. We're going to start from something like this and work our way backward to something like that, where this is the GCF and this is the leftovers. So we're going to do that here. So starting with number 1, the very first step says use the above method to find the GCF of all the terms. So these are my terms. I have 5x cubed and I have 25x squared. We're not going to use the negative. We're just going to leave that there. So I break down 5x cubed into 5 and 3 x's. Okay. I break down 25x squared into 5 times 5 and 2 x's. And then I find what they have in common. Step 2 says write the polynomial as a product. Product means multiply. Okay, we're going to multiply. Of the GCF and the leftover quote unquote factors. So it's the GCF on the outside times the leftovers on the inside. Kind of. So 5x squared on the outside, because that's the GCF. But when I say the leftover factors, what I mean is one thing at a time. Like we're not combining all the leftovers together. I'm going to do first the leftovers of the first term minus, that minus comes from the problem, the leftovers of the second term. Okay, it's going to look, this answer is going to look like this format. So in that first term right here, the 5x cubed, what was left over? X. And then minus comes from the original problem. What was left over from the second term? 5. 5x squared times x minus 5. How could I check this if I wanted to? What does that look like? What property? When something's on the outside of parentheses. It's like distributive property. Right? So this last step says check your answer using distributive. You don't absolutely have to. If you just feel wild and just want to leave your answer. But you can always check it to see if you know if you did it right. So that would look like this. I would distribute this in. That would give me 5x cubed minus 25x squared, which is what I started with. So it's kind of like factoring is a reverse distributive property. Instead of multiplying something through, you're dividing something out. And that thing you're dividing out is the GCF. So that's your final answer right here. You try number 2. Priscilla, how do you factor the first term, 2x cubed? How do I write that out? Long. All right, thank you. Noah, how did you do 12x squared, please? I just wrote what I thought you were going to say. You tell me what you wrote. 2 times 3 times 6. So that would give me 6 times 6, which is 36. Did you mean 2 times 3 times 2? Okay. And then 2 x's? All right. What did y'all find that they had in common? A 2 and 2 x's. How do I write that down? 2 and 2 x's. All right. What am I going to write next? Parentheses, okay. And then it's going to be the leftovers from the first term. What did I have left over? Good. And then plus, that comes from here. The leftovers from the second term, which is 3 times 2, which is 6. Now, I'm not going to check it, but if I wanted to, what would I use? Distributive. Right? I do distributive. All right. Try number 3. Good. Check my answer with yours and raise your hand if you got that right. Okay, very good. What is something, there's a few things. What do you notice is different about these 3 problems on the bottom and the 3 problems on top? There's 3 terms instead of 2. What else? There's pluses and minuses. How is it different at the variables? What do you notice? How many? Yeah, there's an extra variable, right? There's more than one variable. 1, 2, and 3 just had x's, and 4, 5, and 6 now have x's and y's. But it still all works the same. So like, I'm going to show you 4, and then I'm going to let you do 5 and 6 on your own. So 4, starting out with 8x cubed y. If I do a factor tree, 8 is 4 times 2. Which of those numbers factors more? 4, right? So that's 2 and 2. So the first term is 2 times 2 times 2 times 3 x's times a y. And then 10 is easy to factor. That's just 2 times 5. And then there's 2 x's and 2 y's. And then 12 is 2 times 6. And 6 is 2 times 3. So I've got 2 times 3 times 2 times 1x and 3 y's. So I figure out what they have in common. 2x and a y. Very good. So I still write that down, 2xy. I open up some parentheses so I can write the leftover factors for each term individually. So if I'm looking at the leftovers for the first term, what do I have? 2 times 2, which is 4. 2x is x squared. The next thing in the problem was a minus. 5x y squared. And then plus comes from the problem. 3 times 2 is 6. 2y's is y squared. So you do 5 and 6 if you haven't already. I'll give you a few minutes and then we'll talk about it. You didn't get what I'm getting. I'll do one long and one short, okay? So 15x cubed is 3, 5, 3 x's, 1 y. Then I've got 3, 2 x's, 2 y's. And then a 2 times 3x and 3 y's. Here's what they have in common on that problem. Writing 3xy, let me come down here. So 3xy times the leftovers is 5x squared. Minus comes from the problem right there. xy. And then plus 2y squared. Who got that one? Okay. Who didn't, but they get it now? Yes? Okay. And then I'm going to show you how I would do number 6. Like once you get used to these and you feel like you don't need to draw it out long anymore, here's how I do it real short. I first just look at the numbers. And I ask myself, what is the biggest number that goes into 8 and 2 and 6? I think about that for a while. Maybe I do a factor tree if I need to. But otherwise, I just say, oh, it's 2. And then I look at the a's. A cubed, a squared, a. What's the largest number of a's that they all have? It's just 1. They all have at least 1. So you're really looking for the smallest a. It's a to the 1. And then I look at the b's. B squared, b squared, b cubed. And I say, the most b's that they all have is 1. And so then, when I'm going to write the leftovers in parentheses, I just divide out 2ab from each of those, like we did in the last unit. 8 divided by 2 is 4. A cubed divided by a, I have a squared left, and the b is gone. Then in the next term, if I divided 2 out of 2, I'm just left with 1. I divided 1a out of the 2a's, so I'm left with 1a and a b, and then minus 3. The a is gone, and b squared, because there's 2 left. Now, do you have to do it like that? Short? Can you draw it out long every single time if you have to? Absolutely. So what I have for you now is a practice sheet. And let me tell you about the practice sheet.